Okay, in each example, let's find the sum. Okay, before I can tell you to find the sum, you probably want to know what sum is. To find the sum means that it's the answer to an addition problem. So we're going to add these numbers. Okay, so we'll start with 6 plus 5, and then 5 plus 6, and then 4 plus 9, and then 9 plus 4. Not real tough questions, but I'm trying to make a point here. So let's look at 6 plus 5. That's obviously 11. 5 plus 6, 11. 4 plus 9, I think that's 406. No, that's 13. And then 9 plus 4 is also 13. Okay, what I want you to notice is what happened in 1 and 2. Compare 1 and 2, and then compare 3 and 4. Hopefully you'll see a little pattern going on. I can write 6 plus 5 equals 5 plus 6, and I can notice that what I did here was I used the same numbers, but I switched the order. And even though I switched the order, the answers remain the same. That's called the commutative property. And because I used addition, it's called the commutative property of addition. Earth-shattering, isn't it? So what that tells me is when I add, it doesn't matter what order I add in. I can either add the 6 plus the 5 or the 5 plus the 6. Order doesn't matter. Take a look that commute is almost in this word, and commute is to go back and forth. So I can switch the order or go back and forth, and it does not matter. That's the commutative property of addition. Now, I have to tell you, here's where we're going to get a little algebra in here. You have this commutative property, and it holds for these numbers and also for these, but we have to make sure that it holds for all numbers. And to show you that it does, we use letters instead of numbers. So that's the whole purpose of algebra. Everybody says, well, why do I need letters? As soon as they put letters in it, I get all screwed up. The reason there's letters in math is because the letters represent numbers, and they're the general case. That means it works for all the numbers. Let me show you what I mean. Okay. So again, commutative property means I can change the order. And commutative property of addition means I can change the order of what I'm adding. So in math, I can write very simply exactly what I just wrote. 5 plus 6 equals 6 plus 5. But in algebra, I can let A and B stand for any real number I want. Okay, and you now know some of the real numbers, the whole numbers, the natural numbers. Okay, and I can put letters in there instead. So instead of using the 5 plus the 6 equals 6 plus 5, that would be the math. What I could do is I could say, let's let A be 5 and B be 6. And then I could write A plus B. Well, if B is 6, that equals B plus A. So here's how it looks in algebra, and here's how it looks in math. And this says that it works only for this case, but this says it works for any real number, because we would write for all real numbers A and B. Okay, so that means any number I stick in here for A, any number I stick in for B, I could switch the order and I would still get the same answer. That's the commutative property of addition. Okay, so now let's take a second and do the next problem. All right, it says, for each problem below, add and use the commutative property to make a new problem. Okay, so the commutative property says that for any real numbers, A and B, and you don't have to call them A and B. You want to use your own initials, use your own initials, it doesn't matter. Okay, but for any real numbers, it doesn't matter if you switch the order, okay, when you add. So now let's take a look at the problem that's in your workbook. And it says, if I'm given the numbers 6 plus 8, I want to find their sum, which means to add them. So we'll do that. And then I want to write another problem using the commutative property. And remember, if I use the commutative property, it means I have to switch their order. So I'll switch their order. Instead of 6 plus 8, I get 8 plus 6, and I want to find their sum. And their sum is 14. And it better be the same, because that's what the commutative property says, that it will be the same. So if you would stop the video here and do the next two examples, and we'll come back to check your answers. Okay, let's see how you did with your two problems. So the next problem was 7 plus 3. So first we have to find their sum, so we're adding them, and that's 10. Then we have to write a new problem using the commutative property, which would be 3 plus 7, because we have to change the order. We find their sum, and that's also equal to 10. And of course, that has to be true, because that's what the commutative property states. You're probably thinking, well, this is ridiculous. It's so obvious. But this is for later on when we get to harder problems, it's really going to be a valuable tool. Number 3. So you just have to take my word for it. Okay, 8 plus 8. Kind of silly, because watch what happens. 8 plus 8 is 16. Using the commutative property, nothing really great happens, because if I reverse 8 plus 8, I get 8 plus 8. So that just shows the commutative property. Okay. Would you stop the video and do the next problem that's in your workbook? Okay, I hope that problem went okay for you. Let's take a look at it. It's 3 plus 8 plus 5. And the first question says, okay, find the sum of the last two numbers, then add the first number to that sum. So we're going to find the sum of the last two numbers, which is, find the sum of the last two numbers. That's right, last two numbers, which is 13. And then we're going to add the first number to that sum, which is 16. The second one says, find the sum of the first two numbers. So that would be 11. 3 plus 8. Let me write that down so you see what I'm doing. The first two numbers, which is 3 plus 8, which is 11. And then you want to add the third number to that sum, plus 5, and you're getting 16. Notice you got the same numbers, same answer. Actually, I could even add the first and the last number, which is 3 plus 5, and you get 8, and then add the middle number, and that's 16. It doesn't matter how you add these. Well, let me just put into symbols what this told you to do. It told me to add the last two numbers first. If I did not want to change the order to these numbers, if I wanted to leave them in this order, but I wanted you to add the last two numbers first, I could put those numbers in parentheses. The parentheses tell you to do that first. Whatever's in there, you do first. So this would look like this. 3 plus, and you'll learn that you should never take parentheses off until you do a multiplication or division step. 8 plus 5 is 13, and there's your 16. I can show that with parentheses without working it out like this. This is a lot more arithmetic, where this is a lot more algebra. Okay? Algebra says, give me some symbols, do it naturally, one under the other step. Algebra, it's kind of all over the place. You can do it almost any way you want. In the second example, it says add the first two first, and then add your last number. And that, again, of course, is also 16. So let me show you how this looks. If I was to write this with an equal sign, it would look like this. That's the first one. 3 plus 8 in parentheses plus 5 equals, okay, now we're going to put in this next one. 3 plus 8 plus 5. Okay, now notice order did not change. And the easiest way to tell that order doesn't change is to take off the parentheses. I'll put them back on in a minute. It's okay. 3, 8, 5, 3, 8, 5. So they're in the same order, which means this is not the commutative property, because if it was the commutative property, the order would have changed. Okay? But what changed is my grouping, okay? Here, the 3 was hanging with the 8, but now here the 8's hanging with the 5. So who you're hanging with or who you're associating with is changing. That's why we call this the associative property. So grouping changes. And you're adding, so it's associative property of addition. So in addition, I can keep the order, but I can change who I hang with, who I associate with, and I will still get the same answer. And that's the associative property. Let's look at the associative property in symbols. Obviously, if we have 3 different numbers here, we're going to need 3 different letters. We can use ABC, XYZ, anything you really want. So let's use ABC. Let's say ABC is any real number. It would look like this. This is A plus B plus C. And again, now the 3, okay, is the A plus the 8 is the B, and the 5 is the C. And will it look just like this? So this is the associative property in symbols. This is the algebra part, and this is the math part. So again, this is stating that it only works for these 3 numbers. This states I can put in any numbers I want, any real number, and it will work for all of those numbers. All right, now let's take a look at this next problem. We're going to fill in the blank to make a true statement. All right, kind of going back to something you did a long time ago. Let's take a look at this. 6 plus blank equals 6. I think we're going back to school, right? Remember that anxiety? And 75 plus blank. Well, remember, you know the natural numbers, you know the whole numbers, so you obviously, there's no problem answering this question. We know the answer is 0. So let's talk about this. Anytime we start with some number and add 0 to it, we always get back to the same number. We always get back to the same number, okay? That tells me that the identity element for addition is 0, because you always get back your identity. Whatever you start with, you get back to. So that's kind of like your identity. You look at yourself in a mirror, you see your identity. Don't scream, but you see your identity. So the identity element for addition is 0, because anytime we add anything to 0, we get back the anything. Okay, so far we have the commutative property, the associative property, and the identity element for addition, and all of those rules are in your workbook. So let's look at this identity element for addition again. Okay, so we said 0 is the identity element for addition because anytime I add 0 to any number, I get that same number back. So this would be a math example. In algebra, if I let A be any real number at all, I could say A plus 0 equals A, because when I add 0, I get back to where I started first. So that's in symbols for algebra. And all of these things we just talked about, the commutative property, the associative property, the additive identity of a 0 rule, that's all in your workbook. Take a second to do the next example in your workbook, and then we'll come back and look at those answers together. Okay, let's see how you did on those. It wants to know in each problem if it's true or false, and if it's true, state the property. We want to talk a little bit about what that says, what that means anyway. Okay, without doing this problem, we should be able now to determine if it's true or false, okay, just by looking at what's going on. So first, let's look at what's going on here. Okay, let's look at 4, 3, 2, 4, 3, 2. The order did not change. What did change was the grouping. 3 here was hanging with the 2, and now 3 is hanging with the 4. That's allowed. That's called associative property. So this will be a true statement. Watch. Let me prove it to you. 4 plus 5. This is 7 plus 2. This is 9. This is 9. This is a true statement. And we knew that already because we had the associative property. Then you might be saying, well, I could have figured that out by doing this. Well, later on, you're not going to have numbers in there. You may have x's and y's in there. And you may not want to try these for all the types of numbers. You have to understand the property. So this is a true statement, and it's true because of the associative property, because grouping changed. And we say of addition because we don't want to get confused with some other things we're going to do later. Okay? Let's look at the second example. In the second example, we have 4 plus, and let me state this now. If I have a parentheses, I can say the quantity of, because it's like one, that, think of a parentheses as a paper bag. So it's 4 plus the quantity 2 plus 3 equals 4 plus the quantity 3 plus 2. Let's take a look at what's going on here. Here, this is 4, 2, 3, if I think of it without parentheses, and this is 4, 3, 2. By the way, you could have associative and commutative properties working at the same time, but at this level, we will not have that. So let's just take a look at this. 4, 2, 3, 4, 3, 2. So order definitely changed. So if this is a true statement, hopefully we should see the commutative property going on. Well, notice what they did. They have 2 and the 3 have switched places. So it is commutative property, and it is of addition because you're adding. I will prove this to you by showing you that this is true. 4 plus 5 equals 4 plus 5. But it is still commutative because the 2 switched order with the 3 in here. So this is 9 equals 9. True statement again. Commutative of addition. And then there's one last one. So let's take a look at the next example. Again, only if it's true is there a property, because the property tells us that that's a true statement, that that exists. There's something there that makes it true. Okay, so let's look at this third and final example. In this third example, we have 4 plus 2 plus 3 equals 4 plus 3 plus 2. Okay, let's take a look at this. Without parentheses, this is 4, 2, 3. This is 4, 3, 2. Again, it looks like 4 plus 2 plus 3. Just making sure this is very full. Okay. Again, it looks like this is going to be a true statement. Let's take a look. 6 plus 3, right? This is 9. 4 plus 5, this is 9. Oh, they did zap one into us together. Look, they did do that. They have, let's see what happened here. 4, 2, 3, 4, 3, 2. We have commutative property, but we also have a grouping change. Wow, I didn't think they were going to zap us with this one so quickly. Okay? Because definitely our order changed, but our grouping also changed. The 2 is playing with the 3 here, and here the 2 is playing with 4. So this is both the commutative and associative properties of addition. Okay? All right. So that's how you look. The easiest way to look, if order changes, think of them without the grouping symbols or the parentheses, and then they just change if grouping changes. Okay? And then you'll know if it's associative, commutative, or both. I didn't think they were going to zap us with that quickly. Okay. Let's take a look at the next problem. Why do we care about this? Why do we care that the commutative property holds or the associative property holds? Well, let's take a look at this next question. And it just says, find the sum. Okay, find the sum again. That means we're adding. So we got 6 plus 8 plus 4 plus 2 is the first one. And for the second one, 5 plus 0 plus 5 plus 15. And there are 2 others. Okay. Obviously, I know you know how to add this. That's not the problem. The problem is that there may be easier ways to add. For instance, it might be easier here to make groups of 10. If you notice, 8 and 2 is 10. 6 plus 4 is also 10. what I did there is I used the commutative property. I changed the order. I also changed the grouping. Okay, so I actually did both associative and commutative properties there. And we have 8 plus 2 is 10, plus this 6 plus 4 is 10. So the answer to this problem is 20. That's a lot easier than adding them all up from left to right. Because if you did that, you could. 6 plus 8 is 14, plus 4 is 18, plus 2 is 20, just in case you didn't believe me. Okay, but it might be easy to make groups of 10. Okay, for instance, 5 plus 5 is 10, and of course, we just have the 15. We don't have to deal with the 0 because 0 is an identity element of addition, so that shows that we're using that property also, and it makes no difference when we add. And so this answer is 25. So that takes care of 1 and 2. Just might be an easier and more quicker way to add. Okay, let's look at number 3. Should I give you number 3, or is that just, well, I'll tell you what, let's do number 3 together. I'm thinking this one's a little harder. Think about what you might see here before we continue. 27, 52, 13. I'm thinking 27, 52, 13. Okay. All right. Well, this may not be a group of 10, but watch might be convenient here. I see 2 plus 3 is 5. I may want to add these together. That would give me 65. That's really convenient because 5s or 10s are easy to add. And then we have 25. So 65 plus 25, that would give us 90. So we have 90 for that sum. So sometimes it's just easy to group things together. That's the whole point of the commutative and associative property. Okay, last one would be this. 6 plus 3 plus 4 plus 2. Now, these are really easy numbers. You may not want to regroup them. But if you did, think for a second of how you might want to group this before I continue. Okay, you might want to take a look at the 6 and a 4. You get 10. And then 3 and the 2 is 5. And you get 15. So again, it doesn't matter whether you want to do these problems like this or not. What does matter is that we do use the associative, commutative, and that 0 property all the time, and that's what you need to understand. Okay. Well, what happens if the problems get a little harder? All right. Let's look at this problem. Find the sum. Again, find the sum means we're going to add. Okay, here are the numbers. I just want to say something that might make this easier. We got 755 plus 9 plus 6,789. Almost said and there. Okay. Well, we're gonna write these vertically. I like to write them vertically with the biggest one first. Doesn't really matter, but I think it makes it easier. By the way, you're going to learn something about math, that in math, you don't want to squish. You want to write big, and you don't want to squish. Okay? So here's the deal. You might even want to, a lot of people like to do this on graph paper because you can put the little digits in the little boxes, and you can keep them lined up. Or you might just want to make lines. Oh, I'm not very straight, so forgive me here. But you may just want to make lines to keep them lined up. That's up to you. And now we're going to add these. So 9 plus 5 is 14, plus 9 is 23. We're going to carry that 2. 8 plus 2 is 10, plus 5 is 15. We're going to carry that 1. We get 15. We're going to carry that 1. We get 7. So our answer is 7,553. Now again, I'm not really teaching you how to add. I'm assuming you know how to add. I'm just giving you other ways to maybe make some of this a little easier for you. Okay, so that's one thing you can do. Okay, now for the most fun ever that I think in algebra is word problems. I know you all love word problems, but I have to tell you, life's a word problem. Nobody's ever going to say, hey, stop industry and go, hey, could you add 6,780 plus 420? Nobody's ever going to do that. People are going to say, hey, I need to fix my house, and I need this, or I need to do this, and I need this. It's always a word problem. So life's about word problems. So let's take a very simple one. Okay, we have Mary. And Mary has $34. Okay. Then we have Jane, and Jane has $15. Then we have Helen, and Helen, she's the lucky dude. Helen has $20 more than Mary. Oh, has $20 more than Mary and Jane together. Oh, Helen has $20 more than Mary and Jane together. Wow. Helen's lucky. Anyway, and then we want to know the total of all three girls. Okay, well, so we have Jane 15, Mary at 34, Helen 20 more than Mary and Jane together. Okay, well, there's a lot of keywords going on here. First keyword that we want to talk about is total of all the three girls together. So total. Total tells us to add. Total is not a word you see often in algebra. You see it a lot in arithmetic, but not in algebra, but it does mean to add. Then we have this phrase, more than, okay? The phrase more than also tells us to add. But I don't want you to confuse more than with is more than, so watch this. If I have 20 is more than 12, okay? That is not a plus. That is not addition. Is more than, because of the word is more than is the inequality symbol. The is so important because the is changes an addition symbol to an inequality symbol. So 20 is more than 12 would look like this. 20 is greater than or is more than 12. So this is changes the phrase more than. So be very careful about that. But 20 more than Mary and Jane together, that tells me to add. But don't confuse the is more than with the more than. Really, really, really important. Okay, now let's get to this problem. Okay, in this problem, we know what Mary has. We know what Jane has. We know a little about what Helen has, but we don't know exactly how much money Helen has. But we know Helen has $20 more than Mary and Jane together. Well, first we have to know what Mary and Jane have together. And then we could add it to $20, and that's what Helen would have. So let's get Helen's. So Helen equals Mary plus Jane, so 34 plus 15, and that is 49, plus she has 20 more than that. So Helen has $69 by herself. Lucky for Helen. I think Helen should just go out without the other two people. But anyway, okay, all together now, we have Mary with $34, Jane with $15, and Helen with $69. Okay, so now if I add that, we have 9 plus 4 plus 5, that's 18. That's 11, $118 for Mary and Jane and Helen all together. So the answer is $118. So there's a lot of things we have going on here. It's the phrase more than, which means plus. It's the word total, which means plus. It's understanding that more than and is more than are totally different. And it's understanding that in order to figure out what Helen had, we first had to know what Mary and Jane had because she had 20 more than them together. Okay, that takes care of that problem. That was fun, right? I thought that was fun. Okay, let's take a look at our next problem. I hope it's equally fun. Okay. First thing we want to talk about is keywords. You just learned some now. Total, sum. We talked about sum earlier. More than. Okay. Those all mean to add. So let's go over some of the keywords for addition. And this is in your workbook. Okay. Keywords for addition. Example, and let's put that in symbols. I put this line here, so Let me make this all 1 before I don't line it up right for you. Okay. And add is the first one, and that's kind of an easy one. You know when you see add, you're going to add, obviously. And let's say add 7 to 4. That means 7 plus 4, which we could also write as 4 plus 7 because addition is commutative. I want you to be careful about doing that because not every operation is commutative. So I want you to be careful about changing the order unless you have to. Okay, so add 7 to 4 is 7 plus 4. Sum, the sum of 7 and 4. Now this is really important, okay? So kind of listen to this really carefully. Sum means to add. And does not mean to add, not ever. And tells you where the operation sign goes. So sum tells me I'm going to add, but and tells me where to put that plus. So if it says 7 and 4, that's where the plus goes because that's where the and is. But and didn't give you the plus side, the word sum did. The and just told you where to put it. Okay, because you're going to get other keywords that do not mean subtraction. They may mean division, they may mean multiplication, and the and will be there and it will tell you where to put that symbol. So don't confuse the and with a plus. It does not mean plus. Then we have the phrase more than. Okay, 7 more than 4. 7 plus 4, or 4 plus 7. Again, all of these could be reversed because they're commutative, but we don't necessarily want to. And then finally, another one that we haven't really used today, but it does mean the same thing, increased by. 7 increased by 4. Increased by is another key phrase, and it means to add. So those are some of the key words for addition. And we may have others later, but that's what we have so far. Okay. Let's see what's next. The next thing that we can apply this addition to is some little concepts in geometry. And some of the concepts in geometry that you may be aware of are perimeter and area. Now, if you think about what you might know about perimeter and area, perimeter means the distance around a figure, and area means the inside of the figure. So you might want to use perimeter if you were putting a border around wallpaper. You might want to use area if you're painting a wall. You might want to use area if you're laying down carpet, okay, or tile or whatever. So area and perimeter are different, but yet they're really, really important. Okay. Before we talk about area and perimeter, we need to know that there are different polygons. You know what a polygon is? I'll tell you. Polygon. Okay. Well, let's just say polygon. A polygon is a dead bird. Polygon. No, kidding. It's not. No, it's not. It's not a dead word. Okay. Polygons are actually geometric figures made by straight lines, and there are different types. Okay, and they're named by the number of their sides. So let's say 3 sides, 4 sides, 5 sides, 6 sides, 7 sides, 8 sides, 9 sides, 10 sides, and I love the 12, so I'm going to tell you about it. Okay, and this is their name. A 3-sided figure, or a 3-sided polygon, is a triangle. A 4-sided figure, or polygon, is a quadrilateral. Now, I know what you're thinking. You're thinking, you don't know what I'm thinking, but I do. You're thinking square or rectangle. Well, they are types of quadrilaterals. Quadrilaterals like the big name, and squares and rectangles are part of that family. So quadrilateral is the broader figure. They encompass the squares, the rectangles, the trapezoids, the rhombuses. Rhombi, I believe, is the plural of rhombus. Okay, and 5 sides. 5-side is the pentagon. 6 sides is the hexagon. And 7 depends on your book. 7 sides could either be the heptagon or the septagon. Most books use the septagon. 8 sides is your stop sign or the octagon. 9 sides is the nonagon. And if you have 10 sides, we got a decagon. And my favorite to say, dodecagon, if you have 12 sides. Okay, now, why do you care? Well, let's talk about some of these. All right, I want to take a triangle, and I want to find the perimeter of this triangle. Let's talk about perimeter. Okay, this triangle, let's say, has sides of 7 inches on this side, 7 inches on this side, and 5 inches on this side. And I know it's not drawn to scale. It's probably a little lopsided, but give me a break. Okay, so we're going to do the perimeter of this triangle. Now, when you do perimeter, the easiest way to think about this is perimeter, and check out the word in perimeter. Yeah, meters in there, but that ain't the word I want. The word I want is rim, because that's really what I have to think about when I have perimeter. I want to go around the rim of the figure. So really, think about yourself as walking around this figure. This makes up my perimeter. So my perimeter is to add up all of these sides. So it's 7 plus 7 plus 5, which is 19. So the perimeter of this triangle is 19 inches. Pretty easy. Okay, now let's deal with a rectangle. It's in the family of quadrilaterals. What you should know about a rectangle, if you don't, I'll remind you, is in a rectangle, opposite sides are equal in length. So this side is equal to this side, and this side is equal to this side. That's what you know about a rectangle if you don't remember that. Let's take this rectangle that might be 6 centimeters on this side and 3 centimeters on that side. And again, we're going to walk around the figure. If we walk around the figure, we need this side, which we have. We need this side, which I think we have. Because if this is 3, this is also 3. And we need this side, which we also have. Because if that's 6, then this is 6. And then, of course, we need this side. So we have all the sides. So the perimeter. Now, there's quick ways to add this, but simply we could just go 6 plus 6 plus 3 plus 3, right, which is 18 centimeters. So that's the perimeter of that one. Now, the next one, I have to tell you, I made this one because I'm really bad at drawing it, as you probably noticed. But I actually am going to draw it also, and I'll show you one in a minute. Okay, so I'm going to take away this rectangle, and I'm going to put up this next figure. This next figure is called an irregular figure. It's called irregular because you don't really see it much. You're used to seeing triangles and squares and quadrilaterals. That's what you have formulas for. But so this is called it looks like a funky L. But at any rate, I'm going to attempt to draw it. Not so well, but okay. All right, so now on this one I have 2. And these lines are perfectly straight, not supposed to be dipped like that, so bear with me. 6 there. I don't have the units. It doesn't matter right now. 10, 8. Okay. So that was a 6. Okay, so that's what I have. Now, again, let's find a perimeter of this. To find the perimeter, I'm going to walk around the figure. So far, so good. So far, so good. Ah, but here's the problem. I need this side. And I need this side. I have this side. So this irregular shape, I can get the perimeter once I have these two sides. So let's think about this. Since this side is going horizontally, I'm going to look across horizontally, and this side from here to here is 8. So that means from here to here has to be 8. Okay, that means this whole thing from here to here has to be 8. Well, we already know that this piece is 2. Well, if this piece is 2 and this whole thing has to be 8, okay, then this piece has to be 6 because 6 plus 2 is 8. Okay? Now we have to get this piece. Well, since this piece is vertical, we have to look vertically. Well, vertically, we have this whole piece. So we know from here to here, that's 10. So that's the same distance from here to here. Well, we know this piece is 6, so this little piece has to be 4. So that makes that piece 4. So now we have all the pieces we need. We need the 4, the 6, this 2, this 10, this 8. Those are the pieces we need. We add that up. 2 plus 6 plus 6 plus 4 plus 8. You know what's going to happen, don't you? I'm going to run out of room here. Okay, plus 10. And we have 6 plus 4 is 10 if you want to do that. 8 plus 2 is 10 if you want to do that. We have that 10. We have that 6. So we have 36 units, whatever the units are, whatever the units are, inches, centimeters, feet, whatever it is. We have 36 units. So sometimes you have to do more work to get the perimeter than just add up exactly what's there. Okay. I hope you enjoyed this lesson. Get ready for our next lesson, which is subtraction of whole numbers.